Okay, back with some quick math. This is question 4, Cell Technical Math, June paper 2024, paper 1. Right, so this is your function question, and over here we have an exponential function. Before we get into it, let's just look at some of the general things that we should maybe know. So what is the general equation of an exponential function? It's going to be y is equal to a not x, a b to the power of x. Maybe there's a p there, plus q. Right, so these are all of the possible variables that we can have in this equation. Sometimes, or I think with regards to our technical math, at least we don't have this minus p thing, so let's maybe just get rid of it for now. Okay, but remember, it is there. And most of the time this a value is either going to be a plus or a minus 1, right? So plus or minus 1. If I look at the one that we are dealing with here, it is a positive. Okay, so we'll only discuss the fact if it's going to be positive 1 or negative 1. We'll not worry about any other values for now, at least. And then we have the b value, and then we have the q value. Okay, so let's chat about all of these things first, and then let's get into the actual question. So what does a do? Okay, so I mentioned a can either be plus or minus. So you should know an exponential function would look something like that, right? Or maybe something like this, or something like that, or something like that. Those are your 4 options for an exponential function. So what does this a do? If a is positive, that means your y value is going to be positive, so your function will be on top. Okay, it could be on top like that, or it could be on top like this. But if a is positive, the graph exists on top. Okay, on top of the x-axis. That's what I'm saying. This line over here, on top of that line. And then similarly, if a is negative, let me leave this one here. If a is negative, your y values will be negative. What does this mean? That your graph is going to exist at the bottom. So at the bottom, it's either here or it is over here. All right. So I'm going to take that first one again, this one. So again, if a is positive, then I'm going to have something that's on top. If a is negative, I'm going to have something at the bottom. Cool, we've discussed a. Let's talk about the q value. Let's do the q value, and we'll do the b value last. What does the q value do? In all of your functions that you dealt with, you probably have a p and a q, right? That is the trig functions, that the parabola, the straight line, we call it c, right? Plus c. But all of your functions has a plus something, in most cases a plus q. And what does that plus q do? Always this q is going to shift your graph up and down. So this q thing is going to make the entire graph shift up and down. So let's assume I've got like a parabola, and if the parabola went up like 2 units, right, then that q is going to be like a plus 2. Okay, with all of the graphs. So in this case, we have now an exponential function. So an exponential function looks like this. If it did not move anywhere beyond the x-axis, then it's plus 0. But if this graph moves up, let's draw a dotted line here, and let's say that dotted line is at 1, right? Well, y equals 1. Then this whole graph is up 1 unit. So instead of having your asymptote at your x-axis, the asymptote now is at y is equal to 1. So the entire graph moved up 1 unit. So all of your graphs, q is going to do that. Q is going to shift the graph up and down. Let me maybe just write this like slightly nicer. That was y equals 1. Okay, so q shifts your graph up and down. All of your functions does that same thing. We said a either on top or at the bottom. Let's talk about the b value now. All right, so if you have a function and maybe it looks something like your exponential function, maybe it's like 2x, 2 to the power of x, my mistake. That would mean if x is 0, it's going to go through 1. If x is 1, it's going to be at 2, right? So maybe this is 1, and then that's going to be 2. If x is something on my left-hand side here, like minus 1. If x is minus 1, then this is going to be a half, right? Where's a half? Let's put that. A half is probably here. Okay, so what does this look like? It looks like this. So let's get that back. It looks something like this. All right, so when we have our exponential function, I'm going to get rid of most of this. When we have our exponential function, it will always look something like this, or maybe something like this. right? So the one that we have on the screen here, 2 to the power of x, that's going to be this one. Okay, we get some random values and we saw it looked like that. But then the b value, okay, let's maybe leave this one. The b value could also be a fraction. Okay, so maybe I have, well, when I say a fraction, let me specify, it could be between 0 and 1. So let's say maybe b is a half. Okay, and this is to the power of x. If b is in between 0 and 1, then the graph would look like this, is descending. So b is bigger than 1, it can't be 1. If it's 1, it's not going to be an exponential function, it's going to be a straight line. So if it's bigger than 1, it increases, it looks like the one on top. If it is in between 0 and 1, it can't be 0 because you won't have a function. It can't be 1 because it will be a straight line. So if it's in between 0 and 1, then the graph descends, as the second picture we have over there. And then also, you can't have a negative b value, because if b is going to be negative, you don't have a function. Right? If you want to go try and draw it, you can try. You'll end up with a bunch of dots. You won't have a function. Right? What am I saying? I'm saying b, if it is bigger than 1, increase. If it is smaller than 1 and bigger than 0, decrease. So we've spoken about all of the a, b, all of the variables a, b, and q. Well, all of the unknowns a, b, and q, and how they impact our graph. So now when I want to go draw my graph, I already have some kind of idea, right? I have a positive a, so I know it's going to be on top. I have a b value that's bigger than 1. I know it's going to be increasing. I have a q value that's minus 1. So I know this whole graph is going to go down 1 unit. Okay, I see they only want us to draw it at 4.3.1. But I'm going to start by drawing it, and then I'll get back to the other questions that's there. All right, so let's go draw this thing quickly. Here's your Cartesian plane. The q value, let's start with this. The q value was minus 1. So my normal graphs, the ones that I've drawn for you so far, all of them I drew on the x-axis. But now, if my q value is minus 1, this means the entire graph is going to shift down 1 unit. So instead of my asymptote being on my x-axis, my asymptote now is at y is equal to minus 1. Okay, so we mentioned that the graph is going to be on top, so it's going to be on top somewhere, not going to be there. I'm just showing you it's going to be on top, and it's going to increase because b is bigger than 1. Okay, but now we also need to know where the graph is going to go through the x-axis. Okay, because wherever you have intercepts, so touches there or touches there, intercepts are always points of interest. You always have to show me intercepts if there are any. Okay, this graph will have an x-intercept. We need to go figure out where. We can reason through this, or we can do the algebra. So let's do the algebra. The equation is y is equal to 2 to the power of x minus 1. So what happens, in order for us to find, let's say, the y-intercept, you make x 0. So this here, let's go make it 0. 2 to the power of 0 minus 1. 2 to the power of 0 is 1. And 1 minus 1 is 0. So what does this mean? When x is 0, y is 0, this graph is going to go through the origin. Okay? And we know that it's going to increase, so it will be like this. So there we've drawn our graph. I'm just going to label my axes over here quickly. X and Y and everything there. So there is my graph. Let's look at some of the questions quickly. We'll come back to the image as we answer those questions. The first one was to determine the equation of the asymptotes. This graph only has one asymptote, so plural's not right there, one asymptote, and that is at the dotted line we've drawn. Asymptote, what's an asymptote? An asymptote is a line the graph strives towards but never touches. So this dotted line we've drawn in here, the graph is going to get closer and closer and closer and closer to that line, but it's never actually going to touch the line. We're never going to go beyond the line, and that's what an asymptote is. Now remember, an asymptote has an equation. Okay, so if you need to give me the equation of the asymptote, then you are going to say y is equal to minus 1. That's the equation of the asymptote. Let's go back to the questions. Domain. Right, so what is domain? Domain is all possible x values, right? All possible x values. That means what can x be on this graph? So I like to do a vertical line test. The vertical line, that's a vertical line. So I take my vertical line and I move it left and right, and I see, does the graph still exist? So if I draw a line here, that's vertical. Does this vertical line touch my graph? Yes, it does. If I move my vertical line here, does it touch the graph? Yes, it does. If I move the vertical line here, does it touch? Yes, it does. So I move it left and right, and if I get to a point where the vertical line no longer touches the graph, I'll know where my restrictions are. But my vertical line here is always going to touch my graph, because you see these arrowheads that we have drawn here? The arrowheads tell me that this graph continues infinitely that way, and it goes infinitely that way. So our domain for our exponential function, and it will be true for all exponential functions, will be x is an element of real numbers. That means x can be all real values. That's our domain for the exponential function. It will be the domain for all exponential functions. All right, let's go see what the next question was. Next thing, to draw the graph, we've already done that. Great. Determine the equation of t if t equals f plus 3. Okay, let's talk about what this means. Okay, so t is a new graph, and t of x is equal to f of x plus 3. Okay, so our graphs can undergo translations. That means it can move up and down, it can move left and right. And if it undergoes a transformation or translation, then we need to figure out where the new graph is. So what happened with this one specifically? Right, the algebra, maybe let's do the algebra quickly and then try and figure out what that means. So this, we already know what that is equal to. Okay, so let's go in and replace that. Let's go substitute that. We know that that is 2 to the power of x minus 1. They gave me that in the question above, right? And let's add the plus 3 there. So this is now 2 to the power of x minus 1 plus 3. That's going to give me a plus 2. So this is now the new graph, which is t. So we've discussed all of this, a, the b, the q, and now we can see the new q is plus 2. The graph stayed the same, but instead of going down 1 unit, it went up 2 units above the x-axis, right? So from the initial picture, from this picture, the graph that we've drawn simply went up 3 times. So instead of having that asymptote, it's going to have an asymptote at y is equal to positive 2. All right, so let's maybe just chat about this. All of the graphs that you have, if you have your graph and you plus it by any number, let's maybe make it like, okay, if you plus it by any number, this thing here determines how the graph went up or down. It's always going to work like that. If it's a graph plus a constant, the graph went up or down by a certain amount of units. That's our question 4. This video is long enough. We'll cut it here.